In this video, we will try to solve the questions that were asked in GATE Economics paper of 2022. The first question is like this. Suppose that a firm has a technology represented by the following production function. We have y, kl is equal to k to the power x, l to the power x. Okay. Where k denotes the capital, l denotes the labor, y is the maximum output that is possible to produce using capital and labor. X and y are the two positive real numbers. It is also known that the production satisfies the constant returns to scale. Okay, then which of the following is true? X plus y is equal to 0.5, x plus 1 is equal to 1, x plus y is equal to 1.5, or x plus y is equal to 2. Okay, so what we are being given, we have y is equal to k to the power x, l to the power y. Okay, this x denotes the output elasticity of capital and this y denotes the output elasticity of labor. Okay, since we are being told that it has the constant returns to scale, constant returns to scale means when the sum of the exponents, that means x plus y is equal to 1. Okay, when we have the sum of exponents is equal to 1, we say we have a production function that satisfies the constant returns to scale. That means the correct option should be x plus y should be equal to 1. That means output elasticity of capital and labor should be equal to 1. Okay, so the correct option should be here x plus y is equal to 1. Okay, now next question is the Human Development Index reported by United Nations Development Program is based on three components. Two of these components are per capita income and a measure of educational attainment of the society. The third component is, the options are Gini coefficient, percentage of population who have access to safe drinking water, percentage of population who work in non-agriculture sector, or life expectancy at birth. The correct option should be last one. Life expectancy at birth is one of the three indicators that is used in constructing the Human Development Index. Okay, next question is like this. The change in equilibrium output for an equal amount of change in government expenditure and tax is linked to which of the following multipliers? Okay, so we have expenditure multiplier, balance budget multiplier, lump sum multiplier, or tax multiplier. Basically in the correct option should be balanced budget multiplier. That means when our change in government expenditure is equal to change in tax revenue, we say at that time we have a balanced budget multiplier. Okay, so the correct option should be this balanced budget multiplier. Next question is like this. What is the user cost of capital for a firm when rate of depreciation of machine is 20% and cost of financial capital is 15%? Okay, so user cost of capital is simply equal to what we call the depreciation plus rental rate of capital. Okay, rental rate of capital, depreciation is 20% and rental rate of capital is 15%. That means user cost of capital should be equal to 35%. Okay, so the correct option should be this 35%. Next question is which among the following Gini coefficients exhibit highest equality? Options are 0.1, 0.2, 0.5, 0.6. Now when in case of Gini coefficient, 0 denotes the perfect equality, okay, and 1 denotes the perfect inequality. Now we have 0.1. Since 0.1 is closest to the 0, then we can say this 0.1 will denote the highest equality given the four options, and this 0.6 will denote the highest inequality among these four options. Okay, so the correct option should be 0.1. Next question is which of the following committees was set up to address issue related to capital account convertibility in India? Options are Tandon Commission, Abid Hussain Committee, Tharpur Committee, or Percy Mistry Committee. The correct option to this question should be Tharpur Committee was set up to address the issue related to capital account convertibility in India. Next question is Bretton Woods Agreement gave birth to the following organization. Options are GATT, RBI, NAFTA, or ASEAN. Obviously, the correct option should be this general agreement of tariffs and trade. Okay, so the GATT was the birth child of the Bretton Woods Agreement. Next question is which of the following is a test of heterodicity? The options are White test, Jacobera test, Brush Godfrey test, or Young box test. The correct option to this question should be White test. Next question is the law that explains the relationship between income growth and size of government expenditure is appropriately linked to. The options are Wagner's law, Ockham's law, Walras law, or Ricardian equivalence. The correct option is, I guess, this Wagner's law. Okay, the question is like this: consider a production function for an economy is being given as y is equal to a k to the power 0.75 l to the power 0.25. Okay, where k, l, and a are the capital labor and total factor productivity, y is the output. The growth rate of capital and labor are being given as 1% and 4% respectively. That means capital grows at 1% per annum and labor growth is 4% per annum. If the rate of growth of output per annum is 4%, we are being told if the output grows 4% annually, find the growth rate of output due to total factor productivity. We have to find out the growth rate due to this total factor productivity. Okay, so what is our production function? Let us write the production function is y is equal to a denotes the total factor productivity, what we also call the Solo's residual. Okay, it explains that very change in growth which is not explained by capital or labor. Okay, and we have k is the capital and 0.75 denotes the output elasticity of capital, and we have l to the power 0.25. This is our Cobb-Douglas production function. 0.25 denotes the output elasticity of labor. Okay, how much our labor how much our output changes if there is change in the labor. Okay, so how do we solve this question? We take log on both sides. Okay, let me write it here. Take log on both sides first. Okay, so we have log of y is equal to, so we have log of a simply, and the log of k to the power 0.75 will be equal to this 0.75 will become coefficient 0.75 log k. Okay, this is from the law of the logarithm. Similarly, we write plus, then we take this 0.25 and form it as the coefficient 0.25 log of l. Okay, so first step was to take log on both sides. Now we take the total derivatives on both sides. Okay, so taking the total differential, that means the derivative of log y is 1 upon y del y simply is equal to derivative of log a, simply 1 upon a is the derivative of log a, and we take it with respect to a. Okay, del a plus 0.75. Similarly, the derivative of log k is 1 upon k del k plus 0.25. The derivative of log l is 1 upon l del l. Okay, now this del y, if I write it like this, del y upon y is equal to del a upon a plus 0.75 del k upon k plus 0.25 del l upon l. Okay, so what does this del y upon y tell us? It is simply the growth rate of output. Okay, so this denotes the growth rate of output. This denotes del k upon k denotes the growth rate of capital, and this denotes the growth rate of labor. Okay, so we are being given the growth rate of output is being given as 4%. So in place of this I can write 4% is equal to, now we have to find out this very thing, that means del A upon A. Okay, we need to find out the what we call the growth rate of total factor productivity. Okay, so we have here 0.75 del K upon K, means growth rate of capital is being given as 1%. So in place of this I will write 1%. Okay, plus 0.25 del L upon L, that means the growth rate of labor is being also being given as 4% here. Okay, now let us solve it for the growth rate of total factor productivity. So simply if I write it like this, we have 4% first, okay, is equal to del A upon A. Let us denote it by, or let us write it as it is, del A upon A. This denotes the growth rate of total factor growth rate of total factor productivity. Okay, plus now 0.75 into 1 comes out to be 0.75%. Okay, plus 0.25 into 4% comes out to be 1%. Or we can write it like this, 4% is equal to del A upon A, plus this comes out to be 1.75%. Okay, or this del A upon A is equal to 4% minus, if I transpose this it will get subtracted, 1.75%. so this comes out to be 4 minus 1.75% comes out to be so what we have 4.00, we have 1.75, this comes out to be 0.5 that came out to be 2.25%. Consider a lottery with two possible outcomes. 100 rupees will be received with probability 0.6 and 50 rupees will be received with probability 0.4. What is the maximum amount that a risk neutral person pays to play this lottery? Okay, so we have a lottery. Okay, there is what we call 60% chance that the person will get 50 rupees, 100 rupees. Okay, and also there is a 40% chance, 0.4, that means 40% chance that he will receive what we call 50 rupees. Okay, so a person is being offered a lottery in which 60% chance is that he will receive or he will win 100 rupees and 40% chances are that he will win 50 rupees. Okay, we are being told what is the maximum amount that a risk neutral person pays to play this lottery. Okay, how much money that this risk neutral person is willing to pay to play this lottery. Okay, it is actually very simple. A risk neutral person will pay an expected value of a lottery. Okay, so the maximum amount that a risk neutral person will pay to play this lottery will be equal to the expected value of the lottery. Okay, so let me write it here. A risk person, a risk neutral person will pay expected, what we call a expected value of the lottery. Okay, so a risk person a risk neutral person will be willing to pay expected value of the lottery. And what is the expected value of lottery? Expected value of the lottery is simply when we multiply each probability, or what I can say here, when we multiply each outcome with its corresponding probabilities and sum them out, we get the expected value. Okay, so that means 0.6 into 100, That means when we multiply each outcome with its associated probability and sum them out, and here we have a 0.4 into 50. Okay, this very amount of money that risk what we call neutral person will be willing to play this lottery. Okay, so zero point 0.6 means 6 upon 10 into 100 plus this is 4 upon 10 into 50. So this gets cancelled, we are left with 60 plus here we have 4 5s are 20. That means a risk neutral person will be, sorry, it is here 80. Okay, let me write it here. A risk neutral person will be uh, what we call willing to pay 80 rupees to play this very gamble or lottery. Okay, so the correct question, it was actually numerical ability question like this, numerical question. So let me write it here. So it was here 80. Okay, so 80 rupees is the maximum amount that a risk neutral person would have been willing to play this lottery. Okay, thank you. Like this, Tom buys 10 liters of petrol without worrying about price, and Jerry buys petrol of 1000 rupees without worrying about price. What is the elasticity of demand for Tom and Jerry? Okay, so far we need to find out the elasticity of demand for Tom and Jerry. Here we can see Tom buys 10 liters of petrol without worrying about price. Okay, without worrying about price. Now what does this statement means? It simply means if we can draw the graph here, we have petrol on this axis and price of the petrol on this axis. We are being told that Tom demands 10 liters of petrol irrespective of the price of petrol. Okay, so that means if he is buying, let us say here 10 liters of petrol, and he is not concerned about any change in price. Let us say price is here 10, here price is 20. So any change in price, if the Tom buys the same amount of petrol, in this case we can say elasticity of demand for Tom is equal to 0. Okay, we can say that any change in the price of the petrol will not change his requirement for 10 liters of petrol. Okay, by this we imply he has a perfectly inelastic. Okay, so this vertical line denotes the perfectly, let me write it here, perfectly inelastic. Okay, we have perfectly inelastic demand. Okay, by perfectly inelastic demand we mean elasticity of demand is equal to 0. Okay, so this is the statement from the first part of this question, that Tom buys 10 liters of petrol without worrying about price. He doesn't care about the price. If price is 10 dollars or $20, he is going to demand only $10. At that time we say price elasticity of demand is 0, and we say we have the perfectly inelastic demand. Okay, now next part to this question is Jerry buys a petrol of 1000 rupees without worrying about price. Now what does this mean? It simply means in case of Jerry, he requires 1000 rupees worth of petrol irrespective of quantity he will be able to buy for a given price. Or we can say that his expenditure on petrol is fixed, which implies any change in the price will not affect the total expenditure. Okay, so uh, if we can graphically talk about this very stuff, we have petrol here. Okay, and we have the price of petrol. Okay, in this case, since expenditure is constant, we are being told he buys petrol of 1000 rupees, his expenditure is constant, it is demand will look like this. Demand karo, that means let us say if price was we have total expenditure for this Jerry is equal to 1000. Okay, now if total expenditure means price into quantity should be equal to 1000. Okay, let us say if price was 10.
Okay, let me write it here. Or let us say price was 20. If price is 20, okay, quantity demanded will be equal to, let me write it here. If price is 20, total expenditure is constant, what will be the quantity demanded? So quantity demanded will be 20 into 10. Okay. Now let us say if price decreases to 10, then so quantity demanded is 10 initially, total expenditure is constant, fixed here. So 20 into 10 is 1000. If price falls to 10, okay, if price falls again to 10, okay, we have the same expenditure. He only has an expenditure of 1000 rupees. So let me write it here. If price falls to 10, then what will be the quantity demanded? So 10 into 20 will give us again 1000 rupees. Okay, so that means we have 1000 sorry, we have 20 here. Okay, so 20 units of petrol will be demanded, and we can see here 20 into 10 is 1000. He has a fixed expenditure, and here 10 into 20 we have again 1000. In this case, we can say he has a unit elasticity of demand, which means proportionate a decrease in price of petrol here will be equal to the proportionate increase in demand for petrol. Okay, and here we can also see if change in price, okay, if with change in price total expenditure remains constant, we say we have a unitary elastic demand. So in this case, elasticity of demand will be minus 1. And in case of Tom, elasticity of demand is 0. That means any change in price, if it leads to constant constant quantity demanded, okay, we say we have perfectly inelastic demand, and perfectly inelastic demand is denoted by 0. Okay, so the slope is here 0. And in case of this, when we have expenditure fixed, okay, any change in price, if it leads to constant expenditure, we say elasticity of demand is minus 1. Okay.
Another question is, in a competitive market for dry cleaning, the inverse market demand function is being given as P is equal to 100 minus Q. Okay, if we can draw it also here graphically, we have quantity here, price is here. Our inverse market demand function is being given like this. Okay, this is our inverse market demand function. We also call it marginal benefit curve. Okay, where P denotes the price and Q denotes the quantity. The private marginal cost of production for all dry cleaning firms together is given by, we have this total marginal cost of the firms. So this is our marginal cost. So let's denote it here. We have 20 as the intercept. This is our marginal private cost. Okay, also, we are being told the market pollution generated by the dry cleaning process of all firms creates external damage given by the marginal external curve, that is MEC is equal to 2Q. That means in the process of dry cleaning, we also damage the environment, and marginal external cost is being given as 2Q. Okay, we have to find out the socially efficient output of dry cleaning. Okay, how much we will produce at a socially efficient point. Okay, so what we are being given here, we have price is equal to 100 minus Q. This is our marginal benefit curve. Also, let us write it here, marginal benefit curve. Okay, our marginal private cost, let me write it here, marginal cost is equal to, marginal private cost is being given us as 20 plus 2Q. This is our marginal private cost, and marginal external cost is being given us 2Q. Okay, now to find the socially optimal level of output, what we need to do, we need to find out the marginal social cost. Okay, what is marginal social cost? Simply, when we add up the marginal private cost and marginal external cost, we get the marginal social cost. MPC is 20 plus 2q, and our marginal external cost is 2q, which means we have 20 plus 2q plus 2q is 4q. So this is our marginal social cost. Okay, now at socially output level, so socially efficient output occurs where our marginal benefit curve intersects the marginal social cost curve. Okay, this is our marginal private cost curve. What will be our marginal social cost curve? Same 20, but 4q will be our slope here. So let us say, let me write it, let us say this is our marginal social cost curve. Okay, how do we find this? When we add up the marginal private cost and the marginal external cost, we get the marginal social cost point. Okay, so this point will denote our socially efficient point. Okay, this is our socially efficient point, and this is our market efficient point. Okay, so when marginal benefit curve intersects the marginal social cost curve, we get a socially efficient output point. Okay, so what is our marginal benefit curve? That is 100 minus q should be equal to marginal social cost curve, which is 20 plus 4q. Okay, if we transpose this here, we have 20. If I transpose this minus q, it will become plus q here. Okay, which means 80 is equal to 5q, which implies q is equal to 80 upon 5, which is equal to 16. That means at socially efficient output, we will be producing 16 units of output. Okay, so this point denotes our socially efficient point, and this point is our market equilibrium point, or perfectly competitive point. Okay, so the question was asking us to find the socially efficient output of dry cleaning is, so we will produce 16 units at the socially efficient output. That means we have 16 in the blanks here. Next question is Mr. Sharma's consumption preference for tea denoted by X and sugar denoted by Y is given by the utility function. We have U is equal to minimum of 2X and Y. The price per unit of tea is being given as 10 and price per unit of sugar is being given as also 10. Mr. Sharma's total income is 900. The optimum quantity of tea purchased by Mr. Sharma equals, we have to find out the optimum level of tea he will be purchasing. Okay, so what we are being given here, we are being given a min function, that is u x y is equal to minimum of 2x and y. Okay, also price of the tea is being given us as 10. Price of sugar is also being given us as 10, and income of the Sharma is being given as 900. Okay, we need to find the optimal quantity of tea he will be purchasing. Okay, so we have this min function. That means our indifference curve will look like this. Let us denote x on this axis, that means tea, and y on this axis, which denotes the coffee, and we need to find out the optimal level of t. Okay, so in this case our indifference curve will be L shaped. Okay, so we just need to find out the minimum of the two in the given brackets. Okay, so how do we solve this very question? This is actually like the Leontief production function, where a consumer is consuming something in fixed proportions. Okay, so for how do we solve this? We just need to equate this 2x is equal to y. Okay, so first we equate 2x is equal to y. Then what will be our budget constraint? Budget constraint is simply price of x into units of x plus price of y into units of y should be equal to the income. What is price of x? Is being given as 10x plus price of y is also 10. Y should be equal to 900. Okay, to solve the min function, we just need to equate the terms in the brackets and put those very values into the budget function. Okay, so let us say y is equal to 2x, then our budget will be 2x, sorry, 10x plus 10 in place of y we have 2x, so I can write 2x is equal to 900, which means 10x plus 20x is equal to 900. Okay, which means 30x is equal to 900, which means x is equal to 900 upon 30, which comes out to be 30. That means optimal quantity of sugar that he will be purchasing will be equal to 30. Okay, so let us denote here, let us say this is here 30. Okay, and what is the optimal units of what we have, sorry, optimal units of t was in the question. So optimal units of t he will be purchasing will be equal to 30. So here we will have 30, and to find out the units of sugar he will be purchasing, just plug x is equal to 30 here. So we will also get that, that means 10 into 30 plus 10y is equal to 900, or this is 300 plus 10y is equal to 900. So we have 10y is equal to 600, or y is equal to 600 upon 10, which means y will be equal to 60. That means he will be purchasing 60 units of sugar and 30 units of 30 units of tea here. Okay, so this is not necessary. We were told to find out only the optimal value of sugar, sorry, tea here. Okay, so simple thing, just equate the two things in the brackets, plug the value into the budget constraint to get the optimal values of x and y. Okay, so I have made the video on the Leon tip production function or fixed proportion utility function. You can check also this. Another question is, suppose Raju enters the job market at the age of 25 and earns annual income of 6,000 rupees. He retires at the age of 65 and his life expectancy is 75 years. That means he is supposed to die at the age of 75. He does not own any assets. Assume Raju consumes income uniformly over his entire lifetime. What will be the average propensity to consume during employment years? We need to find the average propensity to consume. Okay, so this question is straightly from the life cycle hypothesis. What we are being given here, a person starts at the age of 25, let us write it here. He is working, starts working at the age of 25. Okay, also we are being told that he retires at the age of 65. Let us write here 65, and R denotes the retirement. Okay, and he is expected to die at the age of 75. Let us write here 75, and let us denote D as the death. Okay, he does not own any assets. Okay, we need to find out the average propensity to consume. Okay, but what does the life cycle hypothesis tell us? It tells us, it simply says that individuals seek smooth consumption throughout their lifetime by borrowing when their income is low and saving when their income is high. And what does this mean? It simply means that individuals plan their consumption and saving behavior our lifetime. Okay, here you can see he is only earning in this period from working to retirement. Okay, this is the what we call the income, where the income is generated, and in this period he will also save, and here will be the dis savings. Okay, from retirement to the death he is not saving anything. Okay, now what will be then the average propensity to consume? Average propensity to consume will be equal to, okay, the working period. So that means R minus W, that means number of years from retirement to the start working, divide by the total age, that means D minus W. Okay, that means from what we call from death year, that means he dies at the age of 75, minus the starting year, that means when he starts working, that's 25. So what is our R? R is 65 minus 25 upon D is 75 minus we have W 25. Okay, so this comes out to be 40 upon 50, which means 0.8 will be the what we call average propensity to save. Simple thing, we just write the working period, and to this we divide the all period, that means from working to death, to get the average propensity to save. Thank you. Next question is, the demand curve for tea in Barodia is given by, we have a hypothetical country Barodia, its demand for tea is being given by dp is equal to 40 minus 2p. Okay, p denotes the price, and the domestic supply for the tea in Barodia is given by sp is equal to 2 upon 3p. Okay, tea is traded in a competitive world market and imported into Barodia at a price of 9 per unit. Initially, there was no restrictions on trade. However, as a result of lobbying by domestic suppliers, the Barodian government imposes a tariff of 3 per unit on each unit imported. As a result of tariff, import of tea decreased by how many units? We have to find out the decrease in the units of tea when the import tariff is being imposed. Okay, so how can we solve this? Let us see in a case when there is no tariff. First, we will see what is the quantity being imported when there is no tariff. Okay, now in this case we can see our domestic demand is being given us. Our demand is being given us. Uh, Demand is being given us as Q is equal to 40 minus 2p, and supply of T is being given us as Q is equal to 2 upon 3p. Okay, 2 upon 3p when there is no tariff. And what is the world price? World price is 9 per unit. Let me write it here. I will write here world price is equal to 9. Okay, if I can graph this out to make it more sense here, so let us draw the graph here. We have quantity and here we have the price. Okay, now we have this demand function. Let us denote it by this. This is our demand for tea and this is our supply for tea. Okay, we are being told that world price is 9. Okay, so this is the competitive equilibrium, but we are being told that world price is 9. We can see here that this world price will be lower than the competitive equilibrium. Okay, so it will be also, it will be lower. Let us denote it here like this. This is our world price of 9. Okay, corresponding to this world price of 9, what is the demand? That means what is the demand by the domestic consumers? So I will write it here. So domestic consumers will buy how much amount? So that will be equal to Q is equal to 40 minus 2 into the world price is 9. So which comes out to be 9 2s are 18, this comes out to be 22. Okay, so demand at world price of 9 comes out to be 22. Okay, when the world price is 9, domestic demand is 22, and what is the domestic sellers will sell at, we are being given, so Q is equal to 2 upon 3. Just plug the world price here. We have 9, this comes out to be 3 3s are 9, 3 2s are 6. Okay, so domestic suppliers will sell 9 units. Okay, domestic consumers will demand 22 units. The difference between these two things gives us the import. Okay, amount of import. So we can see here import is imports is equal to 22 minus 9, 22 minus 9, which comes, sorry, it is here 6, 22 minus 6, this comes out to be, we have 22 minus 6 comes out to be 16. Okay, now when we have the tariff, with tariff demand is as it is. Demand will be Q is equal to 40 minus 2P. Supply will remain same. We have Q is equal to 2 upon 3P. Now world price with tariff, let me write it here, world price with tariff. Obviously if tariff is being imposed, uh, the world price will increase by the amount of the tariff being imposed. Okay, so world price will be equal to world price plus tariff. World price was 9 and we are being told that 3 per unit of tariff is being imposed. That means 9 plus 3 is 12. So our new world price will be 12. Okay, so let us denote it by this, by another color. Let us say this is our new world price. Okay, which is 12. Okay, now corresponding to this new world price, what will be the quantity demanded? So domestic consumers will buy how much amount here? So they will buy Q is equal to 40 minus 2 into 12, that is the new price after that tariff is being imposed. So this is Sajji minus Bath Bagai 2, this comes out to be 16. Okay, so quantity demanded at new price is equal to 16. Okay, so let me use another color. So we have 16 units will be demanded when there is import tariff, and quantity domestic sellers will sell will be equal to Q is equal to 2 upon 3. The new world price is 12. So 3 ones are 3 fours are 12, 4 twos are 8, which comes out to be 8. They will be supplying 8 units. Okay, and what will be the magnitude or amount of imports? So imports will be equal to, so 16 minus 8, so this very thing is the imports here. Originally the imports was this much amount, so here imports will be equal to 16 minus 8, which comes out to be 8. Okay, now decrease in imports, decrease in imports will be equal to, originally we were importing 16 units, now we are only importing 8 units. That means decrease in imports due to the tariff is equal to 8. That means imports will decrease by 8 units when there is a per unit tax of 3 per unit given the demand and supply. Next question is, consider the following inequalities: 3p minus q less than 4 and 3q minus p less than 12. Which one of the following expressions below satisfies the above two inequalities? Okay, so we have to see which of these expressions actually satisfy these two equations. Okay, inequations, sorry. So p plus q less than 8, p plus q is equal to 8, 8 is less or equal to p plus q less or equal to 16, or p plus q is 16. Okay, how do we solve these type of questions? First we write the given equalities, that inequalities like this: 3p minus q into equality form. Okay, so we just remove this and write equality. Also here we have 3q minus p, so let me write like first minus p, then I can write 3q. Okay, we can write the terms in any order. Okay, and also remove the inequality here. Now solving for P and Q. Here, if we, let us say this is equation first, this is equation second, multiplying equation, what we need to do, we just need to make the coefficient of either P or Q same in both the equations. So for this, it will be plausible to multiply this equation by 3. Okay, so we have this equation will turn out to be minus 3p plus 3 3s are 9q is equal to 3 12s are 36. Let this be equation third. Now what we need to do, we just need to add up equation first and third. So 3p minus 3p, these two will get cancelled. 9p minus, sorry, 9q minus q comes out to be 8q is equal to 36 plus 4 is 40. Okay, which implies our q is equal to 40 upon 8, which comes out to be 5. That means our q came out to be 5, which means our q should be less than 5. Okay, similarly to find the value of q, p, just plug q is equal to 5 in equation first. So 3p minus the value of q is 5 here is equal to 4, which means 3p is equal to 4. Transposing this will become plus 5, or 3p is equal to 9, or p is equal to 9 upon 3, which comes out to be 3, which is p is equal to 3, which implies our p should be, if we write it back into inequality form, that means our p should be less than 3. Okay, so we have q less than 5, p less than 3. That means p plus q should be less than 5 plus 3, 5. So let me write first the value of p, that means 3 plus 5, which means p plus q should be less than 5 plus 3 is 8. That means the correct option should be p plus q should be less than 8. Then we can satisfy the both equations if p plus q are less than 8. Okay, sum of p plus q is less than 8. The correct option, I guess, should be first option. Next question is, a monopolist has following inverse demand function. P is equal to 40 minus Q, where P is the price and Q is the quantity. The monopolist has zero fixed cost and a marginal cost of 5 per unit of output produced. The monopolist aims to maximize profit. Sorry. Suppose the government imposes per unit tax of 5 per unit of output on the monopolist. As a result, price charged by the profit maximizing monopolist to consumer increases by the options are 0, 2.5, 5 or 10. Okay, so what we are being given? We are being given the inverse demand function of the monopolist as P is equal to 40 minus Q. Okay, and we are also being told that we have a profit maximizing monopolist. That means profit maximization, as we know, requires that our marginal revenue should be equal to the marginal cost. This is our demand function. If I can draw the graph also here. Okay, we have quantity here, price on this axis. This is our inverse demand function. Let us write it as the demand function. Okay, now first we need to find out the total revenue. Okay, total revenue is simply price into quantity, P into Q, which means 40 minus Q. This is our P. To this we multiply Q. This comes out to be 40 Q minus Q square. Okay, now we find the marginal revenue. Simply the partial derivative of total revenue function with respect to quantity gives us the marginal revenue. Derivative of Q is 1, so we are left with 40 minus the derivative of Q square is 2Q. This is our marginal revenue. Also our marginal cost is being given us. We are being told we have a marginal cost of 5. Okay, so let's draw the marginal revenue function like this. This is our marginal revenue function, and we are being told that marginal cost is constant, which is 5. Okay, let us say this is our marginal cost. Now profit maximization requires marginal revenue should be equal to the marginal cost. So we have marginal revenue 40 minus 2q. We equate this with marginal cost of 5 and solving for q, which means 2q. If I transpose this, so we have 40 minus 5 comes out to be 35, which implies q is equal to 35 upon 2, which comes out to be 2 ones are 2, 2 sevens are 14. So this is 17.5. Okay, so here marginal revenue is equal to marginal cost and quantity produced is equal to 17.5. And what is the price corresponding to this point? So what will be the price? Price will be equal to, just plug the value of q in the price function. So we have 40 minus, in place of q we have 17.5, which comes out to be 22.5. Okay, so we have a price of 22.5. okay, when there is no per unit tax imposed. Okay, now when per unit tax is imposed, so when per unit tax is imposed, okay, what will be our new marginal cost? Marginal cost will be equal to the original old marginal cost plus the tax, per unit tax. Okay, so old marginal cost is 5 and per unit tax is being told us it is also equal to 5. So 5 plus 5 is equal to 10. Okay, so new marginal cost is 10. So we can just draw another marginal cost curve. Let us say this is MC, and that means new marginal cost. Again profit maximization requires, so profit maximization requires marginal revenue should be equal to the marginal cost, which is the new marginal cost. Marginal revenue is 40 minus 2q and new marginal cost is 10. Solving for q, so we have 2q is equal to 40 minus 10 is 30, which implies q comes out to be 30 upon 2 comes out to be 15. Okay, so when per unit tax is being imposed, quantity produced by the monopolist is 15. Okay, so marginal revenue, marginal cost intersect at this point, and we have 15 as the output produced by the monopolist. And corresponding to this, what will be the price? Let's calculate. Then price will be equal to, just plug q is equal to 15 in the inverse demand function to get the price. 40 minus in place of q we have 15. Okay, which comes out to be 40 minus 15 comes out to be 25. Okay, corresponding to this we have 25 is the price. Okay, now as a result the price charged by the profit maximizing monopolist to consumer increases by, so originally consumer was paying 22.5. okay, when there was no tax being imposed. When the per unit tax was imposed, the price that the consumer is bearing is equal to 25. That means price has changed from 25. That means from 22.5 to 25, the difference is 22.5, which comes out to be 2.5. that means price will increase by 2.5. okay, the correct option I guess should be 2.5. Next question is O'Connor's law states that a 1% increase in unemployment for 1 year is associated with 2% decrease in GDP growth. Okay, so by O'Connor's law we have, if we have 1% increase in unemployment rate, okay, it leads to a 2% fall in GDP. Okay, suppose the economy has the following expectations augmented Phillips curve. This very expectation augmented Phillips curve is being given by pi is equal to pi e minus beta u minus un. okay, where pi and pi e are the inflation and expected inflation rate respectively. U and un are the unemployment and national rate of unemployment respectively. This beta measures the sensitivity of inflation to unemployment gap. When the value of beta is being given as 2, by what percent does output fall short of full employment, given that the inflation rate, expected inflation rate and natural rate of unemployment are 8%, 10% and 6% respectively. We have to find out the fall in the GDP if we are being given the values of the inflation rate is 8%, expected inflation rate is 10%, and the national rate of unemployment is 6%. Options are 2, 4, 6, 8. Okay, so for this what we will see, first we write this uh, expectation is augmented Phillips curve is being given as pi is equal to pi e minus beta u minus un. Okay, what are the values of the different variables? We are being told that the inflation rate is, that means pi, the value of pi is 8%. Okay, and the expected inflation rate is 10%. Also national rate of unemployment is equal to 6%, and also the value of beta is being given as 2, beta is equal to 2. Okay, now we will put these values in this to get this value. Okay, we will get the value of this u, then this very gap will give us the unemployment rate. Okay, so pi is 8%, I can write here 8% is equal to this expected inflation is 10% minus the value of beta is 2. We have u which we need to find first, minus un, national rate of unemployment is 6%. Okay, we can write it like this, 8% is equal to 10% minus 2u. Okay, multiplying to each of these terms, minus minus is plus, 2 6 are 12%. Okay, so we can do one thing here. If I transpose this 2u here on LHS, it will become positive. 2u is equal to 10 plus 12 plus 10 is 22, 22%. Transposing this 8%, it will get subtracted here, which means 2u comes out to be 22 minus 8 comes out to be 14%, which implies our u is equal to 14% upon 2, which means u comes out to be 7%. Okay, u is 7%. Now what is the unemployment rate then? So unemployment rate will be equal to u minus un. Okay, u minus un, and the value of u we got as 7%, and national rate of unemployment is being given us as un is 6%, so I will write here 6%, which means 7% minus 6% comes out to be 1%. So we have unemployment rate equal to 1%. And what is the relationship between unemployment rate and GDP, which that has been given us in the question per se here. We are being told 1% increase in unemployment will lead to 2% decrease in GDP. Okay, so we have 1% here, we have 1% increase in unemployment here will lead to obviously 2% decrease in 2% decrease in GDP. Okay, GDP. Okay, if here we have, let us say if there was 2 in place of 1, so that means unemployment rate would have been 2%, and this would have mean that 1% so 2% this time 2% increase in unemployment would have led to 4% fall in GDP. But since we got the unemployment rate is 1% only, so our GDP will fall short by 2%. Okay, so the correct option should be A option. Next question is, consider the following system of equations in three variables x, y, z. We have minus x minus y minus z is equal to 3x plus y plus z is equal to 10, 2x minus 3y is equal to 6. Okay, we have to find out which of the following options is correct. The system has, first option is no combination of values x, y, z that satisfy this system simultaneously. Another option is only one combination value of x, y, z that satisfy this system simultaneously. Third option is only two combination of values of x, y, z that satisfy this system simultaneously. And fourth option is infinitely many combinations of values of x, y, z that satisfy this system simultaneously. Okay, so let's try to figure out what I have done. I have just rewritten these system of equations. Here I have multiplied the first equation by minus 1, so this becomes x plus y plus z is equal to minus 3. Then we have the same two other equations. Then I found out the coefficient matrix. That means I formed the matrix of the coefficients of x, y, and z. So the coefficient of x is 1, here also 1. The coefficient of x is here 2. So here we have 1, 1, minus 3, 1, 1, minus 3, 1, 1, 0. Okay. So in place of z, I have written here 0 times z, since no z is involved, so 0 into z is z. Sorry, 0 here. Okay, and this x is the solution vector that we need to find out the value of x, y, z, and b denotes the vector of constant terms. Now to find whether this system of equations has a solution or not, what we need to do, we will be using the Cramer's rule here. In Cramer's rule, first we need to find out the determinant of this coefficient matrix. How do we find determinant? We write this one, okay, and mentally delete this row and this column and take determinant of the remaining elements. So we have 1 zeros are 0, then we have minus, then minus in 3 into 1 is minus 3, so I can write it like this. So we have minus 3, then we have minus 1 from the formula. So mentally deleting this row and this column, taking determinant of the remaining elements. So we have 1 zeros are 0, then we have 2 ones are 2, plus 1. Okay, so first we have plus 1 minus 1 plus 1. Similarly, these change the signs alternatively. So deleting this row and this column, taking determinant of the remaining element, so we have minus 3 minus 2. Okay, so this comes out to be, we have 1 here, so minus minus is plus, we get here 3. Here minus 1 into minus 2 is plus 2. Okay, here we have minus 3 minus 2 is minus 5. So this comes out to be 0. We got determinant equal to 0. Okay, so if determinant is equal to 0, okay, so first we need to find the value of determinant. It came out to be 0. Then we need to find out the determinant of other elements, other what we call a1, a2, and a3. I explained this Cramer's rule in earlier video. You can check this also. For the detailed explanation, I will not be able to give the detailed explanation here. Now to find the a1, okay, that means to get the value of x, we need to form a new matrix a1 such that this a1 is formed by replacing this first column of the coefficient matrix with the vector of constant terms. Okay, so a1 will be formed by, so to find the value of x, just replace the first column with the coefficient of with the vector of constant terms. So we have here minus 3, 10, 6, and the remaining matrix will remain same, 1, 1, minus 3, 1, 1, 0. This is our a1. Similarly, to find the value of uh, y, what we need to do, we first need to find the value of a2. So to find the value of y, replace the second column this time. Okay, we form a new matrix in such a way that we replace second column with the vector of constant terms. So new matrix will be like this: 1 1 2. Then in place of this we write -3 10 6, and similarly we have 1 1 0 to get the value of what we call a2. Similarly, to find the value of z, we form new matrix a3 in such a way that in this case we replace third column with the vector of constant terms. So our new matrix will be 1 1 2 1 1 -3. In place of this 1 1 0 we write -3 10 6. Okay, now if I will write here, if any, what we can say here, if at least one of, that means a1 a2 and a3 is non-zero. Okay, if determinant is equal to 0, which is the case here, and if at least one of these a1 a2 a3 their determinant is non-zero, then we have no solution. Okay, but if a is 0 and determinant of this a1 is equal to a2 is equal to a3, if all the determinant of these is equal to 0, then we have infinitely many solutions. Okay, many solutions. Okay, now let us try to find out if any one of these is non-zero. Okay, so now let's take the determinant of this very a1 here. Okay, how do we find the determinant? Same process. First we write -3. Okay, mentally delete this row and this column and take determinant of the remaining elements. So 1 zeros are 0, then minus minus is plus, we get a 3. Okay, then we have -1, so -1. Now we need to mentally delete this row and this column and take determinant of remaining elements. So 10 zeros are 0, then we have -6, then we have +1, deleting this row, this column and taking determinant of remaining elements. So we have 10 threes are 30, so we have -30, then we have -6 zeros, 6 ones are 6. So let us see what comes the determinant here. So 3 threes are 9, we get here -9. Here we have plus minus 1 into -6 is +6. Then we have -30 into -30 minus 6 is -36. Here we can easily see, we get here, this is 27. So 36 minus 6, so we get here, what we get here, we get here -30. So we get here -39, -39. Obviously a1 is not equal to 0. Okay, so we can safely say this system of equations has no solution. Okay, because we just took the determinant of a1, it came out to be non-zero. Okay, we need at least one of these a1 a2 a3 to be non-zero to get no solution. Okay, so we got that value of a is equal to 0. Okay, and one of these a1 a2 a3 at least is non-zero, which we saw here. So we can say no combination of values x y z that satisfy this system simultaneously. I guess this option should be right if I have done the calculation right. Otherwise, my calculation cannot be guaranteed at times. Next question is, a sphere of radius or centimeter is packed in a box of cubical shape. What should be the minimum volume in centimeter cube of the box that can enclose the sphere. Options are r cube upon 8, r cube, 2r cube, or 8r cube. Okay, so what we are being given, we have a sphere. Let us denote this as a sphere. Okay, it has a radius of r. Okay, and this sphere has to be placed in a cubical box. Okay, in a cubical box, let us try to form the cubical box like this. So I have just formed the top view of the cubical box. Actually our cubical box would be like this very stuff like this. Okay, in this we have to place a sphere. Okay, so I'm just giving the top angle here. Now we need to find out the minimum volume of this cubical box that can in which we can put this sphere of radius r. Okay, so what will be if r is the radius here, then what will be the length of cubical box? So we have here r again. Okay, so this will be the length and it will be twice r. Okay, total length will be 2r. Okay, similarly, since r is same here also, so let us write it like this. So here we have also r and here we have also r. So breadth will be also 2r, and height, obviously height will be also equal to 2r. If we want to find height, will be also 2r. Okay, then the volume of the cubical box, we know volume of a cuboid if we have this very cuboid. Okay, so this is length, this is breadth, this is height. So the volume is simply length into breadth into height. So we have here length into breadth into height. This is our length, this is our breadth, this is our height. So we have 2r into 2r into 2r. So this is 2 to the 4 to the 8. We have 8r into r is r cube. So the correct option, I guess, should be 8r cube. Okay. Next question is a game consists of spinning of arrow around stationary disk as shown below. When arrow come to rest, there are 8 equally likely outcomes. It could come to rest in any of the sectors numbered 1, 2, 3, 4 up to 8 as shown here. Okay, two such disks are used in game where their arrows are independently spun. What is the probability that sum of the numbers on the resulting sector upon spinning the two disks is equal to 8 after the arrows come to rest? Options are 1 upon 16, 5 upon 64, 3 upon 32, or 7 upon 64. So we have two disks. These are being spun simultaneously and independently. We have to find out after these disks come to the rest, what is the probability that the sum of the numbers come out to be 8. Okay, so what can be the combination? The combination can be, let us say this is first, let us say this is spin A, spin B. Okay, so I'm just giving the name to these two disks. So we have A and B, and when they are being spun simultaneously, let us say the combination can be, we can get 7 in A and 1 in B. So 7 plus 1 is 8. Similarly, we can get 6 here, 2 here. Okay, we can get 5 here, 3 here, we can get 4 here, or 4 here, or we can get 3 here, or 4 here, or we can get 2 here, or 6 here in this disk, or we can get 7 or 1 in the first disk, or 7 in the last second disk. Okay, so we have 1 2 3 4 5 6 7. Okay, so 7 outcomes are in our favor. Okay, so these 7 outcomes are in our favor. Okay, so probability of getting a sum of 8 is equal to number of favorable cases. We have 1 2 3 4 5 6 7, so these 7 combinations are in our favor. Divided by sample space. What will be the sample space here? Sample space will be 8 into 8, that means we have 64 combinations. Okay, total number of 64 combinations, out of which only 7 are in our favor. That means those 7 where the sum of the numbers on is equal to 8. Okay, so the correct option should be 7 upon 64. Okay, number of favorable cases upon total sample space.